Hey, this is Robert. Okay, so I'm back. This is part two. I'll briefly run down what we did in part one and write out the answer. Because in part one, I didn't get to write out the answer. Technical difficulties, I could say, of the furry kind. Okay, so we have an infinite series. We said let's write this out as a partial sum of n terms. So we had to start it at the proper index. We did that. We wrote out a whole bunch of terms and we discovered, well, once we broke it up using partial fractions, we found in two different ways, we found that if a is 1/3 and b is negative 1/3, then, and actually you can try this. Go ahead and combine like terms, find like terms, find common denominators and multiply combine like terms on top, and hopefully you get the cancellations on top needed for this to turn into the original. So we decomposed this into these partial fractions. We inserted this a sub k back into our infinite series. Then we wrote out a whole bunch of terms, and we found that the first term, this is what I should write here. Okay. That our, let's see, first and our last term are the only ones that survive. Okay, we write out a whole bunch of terms. We realized in part one, we realized that the first term, k equals 1 into the first term, I should say, remains, survives, which turns into 3 minus 2 is 1. 1 times 3 is 3. And the last term, which n gets plugged into, which has an n plugged into it, whatever n might be, 10 or 999 or whatever you want to go up to, that survives. And everything else in the middle cancels. Kind of nice. So we have a 1 over 3, 3n plus 1. That is our final answer. That is the formula for the nth sum of our infinite series. Now remember when it said sequence of partial sums. Okay, I said don't really worry about that. Don't let that throw you off. A sequence is just a list of numbers, whereas a series is the summation of all those numbers, right? Summation of a whole bunch of terms. So why do they call this a sequence? Well, this isn't a sequence. It's the set of all sums that is the sequence. So if we plugged in n equals 1, then we'll get, whatever term we'll get will be the first term in our sequence here. And then n equals 2, n equals 3, n equals 4. We'll get a whole list of sums, and each sum will be another term in this set, and that set of numbers in order there will be our sequence of sums from n equals 1 to 2 to 3 to 4 and so on. And each one of those is a partial sum that just goes to a different n value. So that's what that means. Now this is your final answer. Thank you very much.